Hello everyone, I am Haricharan and welcome to the video editorial of Education Codeforces on 151, and this was a Div 2 contest. In this contest I was able to solve the first 4 problems. I felt that problem C was a bit too easy and too implementation based, but otherwise I felt it was pretty balanced and a very nice contest. So let's continue with the solutions. So we'll have a look at problem A. You can pause the video and have a look at the question. Okay, so what is the question? We are given an integer n and we want to apply get an unlimited supply of every integer from 1 to k, and we have to generate the sum n, right? Now the test cases are a bit weird obviously, but we'll have a look at the solution. So if you have a look at problem A, the thing we have to notice is that we are given 3 things, n, x and k. Okay. Now let's have a look at the first case in which k is not equal to 1. Okay. Oh sorry, not k, wait, give me a second. Yeah, so if k is not equal to 1, then what can we say? Like if k is let's say greater than 1. Okay. Now in this case that means basically we are allowed to have all numbers from 1 all the way up to k. And of course another case might be k equals 1, and in this case it might not be possible to generate it because 1 is the only number we have, right? So essentially the first check we'll be doing is whether we have 1 or not in our set of allowed integers. So do we have 1 or not? That's a very simple check, right? So if k is equal to 1, okay, if k equals 1 and x equals 1, we cannot do this. We cannot do anything at all, so the answer will be no. Why is this? Because actually our set of integers in that case is nothing, right? So we don't have anything in the set of integers, so we can't do anything at all. So this is definitely a no. So now let's have a look at k equals 2. Okay, if k equals 2, we have 1 and 2 available to us. Okay, now in the case when k is equal to 2, x can have 2 values, right? What are those 2 values? X can be 1 or x can be 2. Now if x is 1, that means we can't have 1 in our set. That means we'll have only 2 in our set. What does this mean? We can only generate even numbers. So even number, the answer is yes. Odd number, the answer is no. X equals 2, what does it mean? That means I have 1 in my set. If I have 1 in my set, I can generate whatever I want, it doesn't matter. Okay. Now let's have a look at the case when k equals 3. K equals 3, in our set we have 1, 2 and 3. Okay. In this case, we should be able to do anything ideally. I'll explain to you why. So if x equals 1, that means we don't have 1 in a set. But even if we don't have 1 in a set, I'm saying it's still fine. Okay. It's still not that big of a deal. So if we have, yeah, right. So basically all this means is if x equals 1, if n is equal to 1, right? If n equals 1, we cannot generate a sum of 1, but we can generate a sum of 2. We can generate a sum of 3, etc., etc. So we can generate all the bigger sums. So in this case, if the sum is even, what we can do is we can have basically some combination such as we can have 2, 2, 2, etc. Right? If n was odd, we can have only 1, 3 and everything else can be 2. But of course this is not possible if n equals 1. This is possible only for n greater than 1. Right? Now if x equals 2, that means I have 1 in my set. If I have 1 in my set, I am guaranteed that I can always keep 1, 1, 1, 1, etc. So I can basically generate any integer. Now this turns out this is not only true for k equals 3, but it's true for k greater than or equal to 3 also. And you can clearly observe why that's true, because we still have 2 and 3. So we have constructed a solution, and of course you can always output all of these things. Here the output will be 2, 2, 2, etc. Right? So in fact let me show you my code also for this. It's basically that only. I have some template stuff here, just a bunch of case work. So you can have look through this over here. It's just a bunch of cases. I don't think it's anything to be worried about, but yeah. So I think that's it for question A. So let's move on to question B, right? So you can again pause it and have a look at the question. Okay, right. So we have 3 people, Alice, Bob and Carol. I think the question statement is pretty clear. So we'll try to draw them on a nice grid, right? So we have A somewhere over here, B is somewhere over here, and let's say C is somewhere over here. Okay. Now, if A is somewhere over here, B is somewhere over here, and C is over here, what should we do? So the first thing we can do is we can subtract the coordinate of this point. We can essentially do a coordinate transform such that this goes to the origin. Why are we doing this? It will make our life a bit easier, because you might notice that the only thing that matters is the relative coordinates. The absolute coordinates don't matter. Like for instance, if my coordinates were 1, 1, 2, and let's say 3, 1, it doesn't matter if I add like 0, 2 to all of these coordinates, right? Because that's just a coordinate transform. We're just shifting the origin, so it doesn't matter. So without loss of generality, I'm making point A to be the origin. So the coordinates of this point will be B minus A, and the coordinates of this point will be C minus A. When I say B minus A, what do I mean? It means I individually subtract the x coordinate and the y coordinate. So I hope that's clear. So now we have 2 points. In fact, I'm going to call this my B, and I'm going to call this C from now on, so as to make my life easier. So B is the above point and C is the below point. So now what can we do? So there are a lot of possibilities, so we'll have a look at all of them, right? First possibility is that there are opposite quadrants. If there are opposite quadrants, then what should we do? So B is somewhere over here and C is somewhere over here. Then what will be our solution? Well, in the shortest path, they'll always move in opposite directions, right? So the shortest path will have a length 1. Shortest path will just be the origin itself. So shortest path will just have a length 1. So I hope I'm being clear in that. Next up, you can have same quadrant. If they are in the same quadrant, then what should we do? Well, if they are in the same quadrant, then let's say both A and B are over here, right? So let's say A is somewhere over here and B is somewhere over here. In this case, how much distance can we travel? Well, we can travel till this distance, right? So we can travel this point together. After that, they have to split up. They can't travel together after that. So in this case, our path will be like this. So in this case, the distance will be minimum of xa comma xb plus minimum of ya comma yb plus 1. Of course, one small correction here is that it's really their absolute values, right? Because they might be in negative coordinates also, so if you take their absolute values here. But I think that should be clear, right? Next case, they belong to adjacent quadrants. Without loss of generality, I'll take that they are both in the upper 2 quadrants, so A is over here and B is over here. Okay. So to make it even more clear, A is somewhere over here and B is somewhere over here. So in this case, we can travel in the common path till over here, but after that we have to split up. So after this, also I think I messed up the naming a bit here. So this should be B here, and this should be C here. So my bad. Also, this should be xc and xb here, and yc and yb here. Just a small typo. Anyways, coming back to the point, this is B here and this is C here. So again here I have to split up. So the common path is just over here. So in this case, turns out that the common path is actually the minimum of absolute value of ya and the absolute value of yb plus 1, right? Likewise, you might have a fourth case in which there are adjacent quadrants, but the quadrants are like this. So B is somewhere over here and C is somewhere over here. In this case, the answer will be minimum of xa and xp, actually absolute values, plus 1. That's it. We have 4 cases here. So it's just a bunch of case work. So I hope that's clear. I'll show you my code also. Okay. First thing, I have a quad function that tells you which quadrant it is in. Also, if you are in one of the axes, like if you are on the x-axis or the y-axis, like I'm just returning that to be either quadrant 2 or quadrant 4. It's just a small correction, so I think that should be fine. So here I'm doing the kind of origin transform thing I told you about, in which we are basically doing a coordinate transform. And after that, so here we are checking if they are in opposite quadrants. If they are opposite quadrants, the answer is 1. Here we are checking if they are in the same quadrants. Same quadrants is the case. here is case 3 I told you about. So if xc and xp, their product is positive, it means basically they both are on the same side. So this basically means they are on the first or fourth quadrant, or they are on the second or third quadrant. So I hope I am being clear on that. Likewise, this means they are on first and second quadrant, or third and fourth quadrant. And we should never hit this, so I just outputted an A here just to check if my code was fine. We don't need this really. Okay. So I think that's it for this question. So let's move on to the next question. Okay. Right. So again, you can pause this and have a look at the question. Okay. Right. So here what are we given? Well, we are given m, and notice that m is equal to 10, and 10 is very small, right? So let's say each of the characters of our final password. So final password is some pass, right? So each of the final characters, they belong to some range L to R basically, like Li to Ri basically, right? They belong in this range. For instance, the first character belongs to the range L1 to R1, second character belongs to the range L2 to R2, third character belongs to the range L3 to R3, and so on and so forth. So L is a string that we are given. And essentially pattern matching this, or we are basically checking this if it's this is some substring basically, not necessarily contiguous. If it's any substring or any basically any substring of the given string. Okay, right. So our given string has a bunch of characters, right? So let's say something like 1, 2, 3, 4, and then let's say 0, 1, 2, 3, 1 or something like that. Okay. Now, first thing we have to notice is that we want to generate a password that is not in a string. Okay. So we have to notice that the different indices are independent. So the first digit can be anywhere between L1 to R1. It can be anything in L1 to R1, no issues, right? Now, can you see that we can just use a greedy algorithm here, and it's always better to basically choose that index which occurs last in the string. So I'll explain. So let's say L1 was equal to 1 and R1 was equal to, let's say, 3 for instance, right? That means first digit can be 1, 2 or 3. First digit can be 1, 2 or 3. It is always better to choose 3. Why is that? Because 3 occurs later on in the index. Since 3 occurs later, the latest in our string, it's always better to choose 3. Because essentially that will ensure that our password is more probable, basically is more likely not to be in the original string. So I hope I am clear on that. So instead, if this was, let's say, something like, let's say L was, let's say, 2 and R was, let's say, 4, and we're string was something like 4, 3, 5, 2, 1, 9 or something like that. In this case, you can see that it's always better for the first character that we choose 2. Why do we choose 2? Because 4 occurs, 3 occurs, then only 2 occurs. So it's always better to greedily choose 2. So that's basically the algorithm here. So you can just have a look at all the numbers in the range L1 up to R1. We can find the last of this, right? You can find the last occurrence of this, if you want to put it that way. Now, basically our given string S, right? So our given string S, we might have L1 in it, we might have L1 plus 1 in it, we might have L1 plus 2 in it, all the way up to R1. Now, right? All of these are in our given string. Fine, okay. Now, what do we do? Well, you see that this we hit this at some last index, right? Now, for the remaining part, let's check L2 all the way up to R2. So, in the remaining part of the string, we can essentially check L2 all the way up to R2. So, like in the next piece of the string, we are checking essentially L2 all the way up to R2 if that occurs. If all of those also occur, you are checking L3 all the way up to R3. Okay. Now, if till LM to RM everything definitely occurs, then we are actually then the answer will be no, because that means basically whichever possibility we choose, like anything from this we choose, 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 it's not possible. But in case we don't have all the way up to like this final set, basically in case we don't have all of that, we will have some possibility, so the answer will be yes. So that's the basic idea here. So I'll quickly show you my implementation also. Okay, so I have some template stuff here, you can ignore that. So I'm just taking inputs all over here. So what is current here? Essentially I'm storing all of these indices in current. So I'm storing all the indices L1 all the way up to R1 in a set called current. There are many different data structures you could use here, maybe a frequency array or something, but I'm just using a set because I feel that was a bit easier. So to initialize, we are inserting everything from L0 all the way up to R0. Notice that the limits are inclusive here, so don't forget that. But yeah, so I'm adding everything from L0 all the way up to R0 here. You might notice that they are actually strings or characters, right? So L0, we are not taking them as integers, we're directly taking them as characters, but even that's fine. That shouldn't be a problem. So I'm using characters everywhere here, no strings, but I think that's fine. So if you find SI, that is the ith character of the string in the set called current, that means just erase it. Okay. Now if the current dot size is equal to 0, what does that mean? That means basically we have exhausted this L1 all the way up to R1, right? So we basically exhausted everything. In that case, what do you do? So in that case, we'll increment ind plus plus. So we just incrementing this variable called index here, and then again what we are doing is we are just doing like basically we are inserting that in a current again. So we are inserting all the desired indices in current again, right? So I hope that makes sense. Now again we are breaking out if ind is equal to n. So if ind is equal to n, that means I have basically found everything in my like every single piece like this. So every single L1 all the way up to R1, all of those have been found. So that means I'm just breaking out of the string. So if I equals n, okay, I equals n, that means the answer is yes. Why is the answer is yes? Because if I equals n means basically I went through the entire loop without breaking out. So since we didn't break out anywhere, that means there is some indices which are not found in the given string. So that means the answer is yes. So if I equals n, I'm just outputting yes here. Otherwise, I'm outputting no. So I hope I'm clear on solution of C. Okay. So let's move on to the solution of D. Again, you can pause the video and have a look at the question. Okay, I'll move on to the solution. So, so in fact, let's have a look at the test cases first, right? So we have 3, -2, 1 and 2. So we'll have a look at some intuition before we start with this. So if you choose a very small k, just a very small k, what will happen? Well, the issue with choosing a very small k is the following thing. So if you choose like a tiny k, in that case, what might happen is the following thing. Okay, so in that case, basically, we won't be utilizing the k property. So essentially, we won't be getting rid of any negative numbers. Why is that? Because everything will be greater than k. Let's say I take k equals, let's say, -1e 18 or something, like -10 power 18. Because we won't be getting rid of any negative numbers. So even that's very bad. If you choose a very large k, let's say 1e 18, again it's the same issue. We won't be getting rid of anything. So if it's very large k, we won't hit k in the first place. If k is enormous, we will never be having a sum of k. So it's not possible that it is decreasing after that. So I hope I'm making sense in that. So yeah, so let's move on. Now, how do you find the desired k? So if you look at the test case, that was 3, -2, 1 and 2, right? Now, assume that I'm choosing k to be some prefix of this. So what is k? K is just any random prefix of this. So I've broken this array in a particular point. K is the prefix. Now, what will be my sum added to the right? So basically, what will be my total sum of the array, or I think they called it value of the array, I think, or the total rating of the array, right? So what will be my rating at the end? The rating will be k plus something. Okay, something is greater than or equal to 0. That much I can tell for sure. So if I have chosen k to be some prefix of the array, then my rating will definitely be k plus that prefix. Sorry, k plus something. K k plus some positive quantity, because my rating can never go down lower than k, right? But of course the biggest question is, what is that positive quantity on the right? So we'll have a look at that. So what we have to notice is that, so we'll have a look at all the suffix sums now. So what are suffix sums here? Suffix sums are 2, 3 and 1, right? Now can you intuitively see that the largest suffix sum will always be this term? So basically the largest suffix sum to the right. So the largest suffix term to the right will always be like this term. So let me give you some intuition of why that's true, because basically whenever you have the largest suffix sum, anything to the left of that, so if there is anything smaller than that, that will basically be removed by the negative. So essentially what will happen is the negative sign will get rid of that. So the rating we get will be the largest suffix sum possible, right? So and like, as I'm being clear, I think anything else will be gotten rid by the negative sign. Okay. So I hope I'm making sense of that. So basically what will be my solution? So I have some array, right? So I have some array. Okay, I'll actually explain this test case a bit more, I think. So if I choose 3 minus 2 1 2, there are actually 5 different breakpoints. So I can break it over here. So if you break it over here, I have to choose k to be equal to 0. Okay, k is 0. What will be my rating? So if I break it over here, my corresponding rating will be plus 3, minus 2 is 1, and 1 plus 3 is 4. So my rating will be 4 in this case. Okay, break it over here, what will happen? In that case, actually k will be 3, and here is where we actually generate the maximum value of 6. Now again the prefix sum is 1, so I'll choose k to be 1. So if I choose k to be 1, then the sum I will be generated is 4, because here the maximum suffix sum is 3. So if I break it over here, the answer will be 4. If you break it over here, again the answer is 4. And if you break it over here, the answer is again 4. Here actually k also will be 4, and the answer also will be 4. Okay. Now you might ask a very small question of why do I chase k to be a prefix always? Because I think that should be pretty intuitive. K is always some prefix of the array. Not necessarily prefix, could be like 0 also, but it's 0 or some prefix of the array, because if I choose anything else, essentially I will be losing some amount, because like if I have some negative number to the right of positive number, I will basically be losing some value. That's essentially why we are always like take k to be prefix of the array. So I hope I'm being clear on that. So if I look at the algorithm, basically it's just iterate over all basically breaking points, right? So basically iterate over all the breakpoints. I'll also have some max value, max rating essentially. I'll call that max rating, max rat. Initially, let's initialize as to minus 10 power 18. We're iterating over all breakpoints, and then what we are doing? So what will be the current rating if you break this at this point? If you break it at a particular point, current rating will just be like whatever k you choose at that point. Essentially, you choose k to be the prefix of that, right? So it's essentially the prefix of I. If the breakpoint is some I, it will be prefix of I plus the maximum of suffix of I, right? Also, one small implementation catch is the suffix of I has to include 0 also. So ensure that you include 0 in the suffix of I. Now, so rating will be this thing. If max rating is smaller than rating, so if this condition is true, if our maximum rating is smaller than our rating, then actually what do we do? So if the answer was m, right, then we just choose answer to be equal to k. So answer will just be equal to prefix of I. Actually, that's what we took to be k. Okay. So I hope I'm being clear on that. So we're just doing a iteration here. Also, it's not max of suffix of I exactly, it's suffix of I to the right. So I hope I'm clearing up that also. Okay. Now, anyways, how do you find the maximum suffix of I? Well, you just throw all the suffixes in a multi-set. I mean, there are many different data structures you can use, but just throw all the suffixes to a multi-set. And after you throw them into a multi-set, basically you can find the largest element in a multi-set in O of log n time. So I think that should be enough for this. Okay, so I hope I'm being clear in that. So let's have a look at the implementation also. I got a couple of minus ones because I forgot this initial case. So I basically forgot that you could break it over here also. So even breaking it, like having k value 0 is a possibility, and I kind of neglected that. So that's one more reason. But yeah, so let's have a look at my solution. So all of this is just taking input. So here is the multiset I mentioned to you about. It's just the multiset of all the suffix sums. So here I'm just inserting 0 to this multiset over here. After that I'm just inserting all the suffix sums. As you can see, I'm iterating from n minus 1 all the way up to 0. Okay. So then what am I doing? I'm initializing k to be equal to 0, and I'm taking mx ans to be the maximum value of a suffix sum. So this is the breakpoint being over here. So this is basically that case in which the breakpoint is at the 0th index basically. After we are having a look at all the other breakpoints. So L cur is basically the prefix sum. It's the sum up to that point. So then I'm erasing like this current element from the multiset, because we can't have this element in the multiset, so we have to keep erasing elements from the multiset. And then I'm finding the maximum value. Basically, s.r begin generates the maximum value of a multiset. If you didn't know this already, multisets are stored in sorted order basically. So in fact, let me explain that also. So if you have some multiset, let's say 1, 1, 2, 2, 3 or something like that. Multisets are always in sorted order. So if you want to get the maximum element, you can just do multiset like s.r begin. S.r begin will give you a pointer to this. So if you basically find the value of this pointer, then you can get the maximum element. Because you can get the minimum element in s.r big. Oh, sorry, this should be s.begin. Sorry, you can get the minimum element in using s.begin. Okay, so you can do that. And again, answer is the rating basically. If the rating we generate here is greater than maximum answer, then you can just choose maximum answer to be this answer, and we can choose k to be the corresponding prefix sum, and I'm just outputting k over here. So I think that's it. So if you have any doubts, you can put it in the comment section. Hope you enjoyed this. Ensure that you subscribe. Thank you very much for watching. This is Harichal.